Welcome to our channel. Please like and subscribe. What is nuclear energy? How tiny atoms create massive power. Imagine this: a single uranium fuel pellet, small enough to fit in the palm of your hand, contains as much energy as nearly 1 ton of coal. Think about that for a moment. Something smaller than a marshmallow, powering entire cities, lighting millions of homes, running hospitals, trains, factories, and even space missions, all because of something happening inside tiny invisible atoms. And today, we are going to slow everything down and explore one of the most powerful, misunderstood, and fascinating technologies ever created by humanity. Nuclear energy. What is it? How does it actually work? And how can something so unbelievably small create such massive amounts of power? Let's begin. Everything around you, your phone, your chair, the air, your body, even distant stars, are made of atoms. Atoms are the tiny building blocks of the universe, so small that millions of them could fit on the tip of a pencil. And inside every atom, there is a center called the nucleus, tiny, dense, and packed with energy. Most of the time, that energy stays locked safely inside, but under the right conditions, that energy can be released. And when it is, the amount of power created is absolutely enormous. This is nuclear energy. Now, to understand how this works, we need to talk about one special element: uranium. Uranium is a heavy metal found naturally in rocks deep underground. And one type of uranium, called uranium-235 or U-235, has a very unusual property. Its atoms can split apart. This process is called nuclear fission, and nuclear fission is the heart of nuclear power. So imagine a uranium atom like a tightly packed ball. When a tiny particle called a neutron crashes into it, the atom becomes unstable. It shakes, wobbles, and suddenly splits into 2 smaller atoms. But something incredible happens during that split. A massive amount of energy is released, mostly as heat, and at the exact same moment, more neutrons fly outward at high speed. Those neutrons then crash into other uranium atoms, which split again, releasing more energy and more neutrons, which split more atoms, again and again and again. This is called a chain reaction. One atom splitting triggers another, then millions, then billions, all happening incredibly fast. Now here is the important part. In a nuclear bomb, that chain reaction happens uncontrollably, almost instantly, creating a huge explosion. But inside a nuclear power plant, Scientists carefully control the chain reaction slowly, safely, steadily. So instead of an explosion, you get a continuous stream of heat, and that heat is what produces electricity. Now, let's walk through exactly how a nuclear power plant works, step by step. Deep inside the reactor, there are fuel rods, long metal tubes filled with uranium pellets. Remember those tiny pellets we talked about earlier? Inside the reactor, the uranium atoms begin splitting, producing heat, a tremendous amount of heat. That heat warms water, but not just ordinary warm water. The temperatures become incredibly high, hot enough to create steam. And steam is extremely important because steam spins giant turbines. Picture enormous metal fans spinning thousands of times per minute. As the steam rushes past, the turbines begin turning, and connected to those turbines are generators, machines that convert motion into electricity. The spinning turbines create electrical energy, which travels through power lines into cities, homes, schools, businesses, and eventually to your light switches, your computer, and your devices. So when people say nuclear energy produces electricity, what they really mean is nuclear reactions create heat. Heat creates steam. Steam spins turbines. And turbines generate electricity. In some ways, it is surprisingly similar to older power plants. Coal plants also boil water. Natural gas plants also create steam. The difference is the source of the heat. Coal burns fuel. Gas burns fuel. But nuclear plants split atoms. And because atomic energy is so concentrated, the amount of fuel needed is incredibly small. That is one reason nuclear power is so powerful. Now here is something even more amazing. Nuclear energy produces almost no carbon dioxide during operation. That means nuclear plants can generate enormous amounts of electricity without pumping huge amounts of greenhouse gases into the atmosphere. And this is why many scientists believe nuclear energy may play an important role in fighting climate change, especially as the world demands more electricity every year. Now, at this point, you might be wondering something important. If nuclear energy is so powerful, why are people afraid of it? The answer comes from radiation. Radiation is energy traveling through space, and nuclear reactions produce radiation naturally. Some radiation is harmless. In fact, you are surrounded by natural background radiation every day, from sunlight, rocks, soil, even bananas. But high levels of radiation can be dangerous. That is why nuclear power plants are designed with massive safety systems. Thick concrete walls, steel containment structures, cooling systems, emergency shutdown systems, and layers upon layers of protection. Because controlling the reactions safely is absolutely essential. Now, there have been famous nuclear accidents like Chernobyl and Fukushima, events that changed how the world thinks about nuclear power. These disasters were serious, and they revealed important weaknesses, but they also pushed engineers to redesign reactors, improve safety, and create stronger emergency systems. Modern nuclear plants today are far safer than early designs, though debates about nuclear energy still continue. Some people believe nuclear power is essential for the future. Others worry about risks, cost, and radioactive waste. And that brings us to another important topic: nuclear waste. After uranium fuel is used for a long time, it becomes less effective, but it also remains radioactive, sometimes for thousands of years. That waste must be stored carefully, usually in special cooling pools or heavily protected containers. Scientists around the world are still searching for better long-term solutions, including advanced recycling technologies and newer reactor designs. Now, here is something fascinating. Not all nuclear reactors are the same. Some reactors use water, others use liquid metal, some use gas, and new experimental designs called small modular reactors may completely change how nuclear power works in the future. These smaller reactors could potentially be safer, cheaper, and easier to build. Some scientists even hope future reactors may eventually use nuclear fusion, which is completely different from nuclear fission. Remember, fission splits atoms apart. Fusion combines atoms together. Fusion is the same process that powers the sun. And if humans can fully control fusion someday, it could provide nearly limitless clean energy with far less radioactive waste. But fusion is incredibly difficult. Scientists have worked on it for decades, and while progress is happening, we are still not fully there yet. Still, the idea is extraordinary, powering cities the same way stars power galaxies. Now, think again about where we started. A tiny uranium pellet, smaller than your thumb, holding immense amounts of energy. Energy hidden inside matter itself. This idea completely changed human civilization. It transformed warfare, medicine, science, engineering, and electricity production. Nuclear technology is also used in hospitals to treat cancer, sterilize equipment, and perform medical imaging. It helps power submarines, scientific research stations, and spacecraft exploring deep space. In fact, some spacecraft traveling beyond our solar system use nuclear energy because solar panels become too weak far from the sun. That means, even at the edge of human exploration, tiny atoms are still helping humanity move forward. And perhaps that is the most incredible part of all. Inside every atom, there is hidden energy, invisible, silent, waiting to be understood. And humanity learned how to unlock it, not through magic, but through science, through curiosity, experimentation, mathematics, and decades of discovery. So the next time you flip on a light switch or hear people debate nuclear energy, you will understand what is really happening. Tiny particles colliding inside atoms, creating heat, producing steam, spinning turbines, and powering entire civilizations, all from forces far too small for the human eye to ever see. And as technology continues evolving, as scientists design safer reactors, cleaner systems, and perhaps one day master fusion itself, the story of nuclear energy is still being written. Because somewhere right now, inside a quiet reactor, deep behind thick steel walls, billions of atoms are splitting, releasing invisible energy, moment by moment, second by second, powering the modern world. That was excellent. Please like and subscribe for daily lessons. See you next time.